Alrighty, friends, we are going to split 2.5 into 2 days. One is going to be big brain and one is going to be calculator usage. And so today we're just going to do these 3 examples and then we'll focus on that part of the worksheet. Okay, so this is something you probably have not seen in your previous classes, so let's really tune in. Sometimes data from an exponential function does not display a proportional growth pattern, meaning you can't tell by the y values that it's being multiplied by a certain number, which means that there's a vertical translation, meaning there was a number added or subtracted. So if you normally would have f of x equals a times b to the x, you'd be able to spot that it's been multiplied by whatever the b value is. But if you have plus or minus some k value, it's not obvious by looking at the original numbers in the table. So here's the key of what we're doing. If we can add or subtract a constant from the output values, or the y's, to reveal a proportional growth pattern, then the initial function was also exponential. This is going to take a big chunk of your brain to do. Once you've done it a few times, the mechanics of it are not impossible, but it is a totally new concept. So what is this going to look like? Here's our concept, even though this is, I'm going to actually extend this down here because yes, it's an example, but without this example, we don't know what we're doing. So selected values from several exponential functions are given in the tables below for each, because it's telling you that it has an exponential format. Find the constant, so that's going to be that k value up here, that could be added or subtracted to the output values to reveal a proportional growth pattern. Then write an equation. We have 2 methods. One's going to be with the calculator, which is day 2, and one is going to be with your big brain, which is right now. This is going to be the format of your starting block. And then if you have equal length input intervals, so like you can see here that these are going up by 1. We will have that in all of our problems. Then we're going to choose 2 points from your table, and you're going to set up 2 equations. And in this process, you are going to find k and a, because in order to find 2 variables, we need 2 equations. So in these steps here, we'll come up with both of those values. And then your equation's k value is the vertical translation number. So that's why it's located over here. So it depends on what they're going to ask you. If they ask you what the vertical translation is that's taking place, you're going to just talk about the k value. But if they're going to ask for the entire equation or the model, like they would up here, then you would have this entire thing when you're done. Okay, let's show ourselves how to do this. So first of all, it told me it's exponential, so I know that that's true. But when I look here, the difference is 6, then the difference is 12, and 24, and then 48. Okay, so I'm not, like, I can't look and say, oh, these numbers are doubling or these numbers are tripling. And so I can't establish the B right away. So some of you are going to see the patterns without this process and some aren't. So I want to show you the process. Now that I've found my differences, you can see that that got doubled, and that got doubled. So what that is going to reveal to me is that when I go to set up my equations, my B value is going to be 2. That's going to be a key thing. Now we need to set up 2 equations to find our 2 variables. I'm going to pick these 2 points to do so. Keeping in mind that basically our problem is y equals a and then b to the x power and then plus some k value. And we do not know x and we do not know a and we do not know k. So let's set up 2 equations. Let's do these guys first. So if we use that initial value, I'm going to have a y value of 7. My a value is unknown. My b value we established through this previous process was 2. My x value is 0 in this particular point, and I don't know my k value. But I do know that 2 to the 0 power is 1, so I end up with 7 equals a plus k. And so I'm going to get my K value as an expression with A in it. And I'm moving that A over by subtraction. So I'm going to keep this sitting around. But I need another option. So I'm going to also write an equation for this second one. And I'm following the same format. Y equals my unknown A, my B value of 2 to the power of 1, because that's the X value in this, plus K. So that simplifies to be 13 equals 2A plus K. All right, but K can be substituted with 7 minus A. So what I'm going to do is I'm going to take my problem and I'm going to put that, well here, actually let's do it this way. This might be easier for you. Let's solve this one for K as well. To get K alone here, I need to take away the 2A. So if K equals 13 minus 2A and K equals 7 minus A, then 7 minus A has to be equal to 13 minus 2A, and we can start solving from here. So if I add the 2A over here, I'll have 7 plus A is 13. And if I take away the 7, I will find out that my A value is 6. So I'm going to be building a function in exponential form. I need an A value, which I just found, a B value, which I found in my initial process from the table. X will stay X, but now I have to find K. And honestly, there's two ways I can do it because K equals two things. Clearly, the green one is easier. So I'll find my K value by taking 7 minus what I just got for A. And in this case, that is going to be a positive 1. So I'll add a positive 1. So this was an exponential function, but that vertical translation of up 1 made it so we couldn't tell if that was going to be exponential as well. Like it wasn't visible to us. Okay, I mean, looking back, you can probably be like, oh yeah, this is 7 times 2, but you got to take away 1. I mean, and so finding that pattern and turning it into an equation is super confusing. So you're better off using this 2 equations method. So let's go through it 2 more times together, and then you're going to try it a few times on your homework. Okay, so I am told that these are all exponential. So I know that I'm looking for a g of x equals a times b to the x and then plus k. Let's use this first. So g of x equals my unknown a. Oh, sorry, let's find b first while I have room by the table. Let's do that first. So this is going to go up 8. This is going to go up 24. And then this is going to go up 72. This is the worst 24 in the universe. And then this last one goes up 216. Okay, well, this is times 3. This is times 3. And this is times 3. So this is telling us that we have a b value of 3. So ultimately, when I'm done, I have to find my a value, but my b value will be 3 to the x power. Now I have to find my a, and I need to find my plus or minus k. So what I was starting to do before is to take the first y equals the a I'm finding. I know that b is 3 from my work down below, to the x power, but in this point the x is 0, and then plus k. That simplifies to be 2 equals 3 to the 0 is 1. So a plus k. So k will equal 2 minus a in that first scenario. Let's do the same process with the second point. And you could really use any of them. I guess I'm in a habit of using the first two. So my y will equal my a. And then in parentheses, I'm going to have my b to the x power of 1, because that's what my x value is in this place, plus k, which will simplify to be 3a plus k. So k will be 10 minus 3a. So now I have 2 statements about what k equals. And from good old geometry, if both of those equal k through the transitive property, they equal one another. Now I can solve this for A. And so here I'll take that 2 away to the other side, and I find out that A is 4. Now you're gonna have to show all of your steps, so try to keep your work relatively organized. So now I know that this will be a 4. So then I take that on the road either to here or to here to find K, and I'm gonna use the easiest one, which is 2 minus my A value, giving me a K value of -2 to put in here. So this is the exponential equation that ties those X's to those Y's. If I had like my way, I would ask you to turn off the video, try this last one, and then watch and see if we did it the same way before we tackle homework on this. Okay, so let's see. This goes down by 32. This goes down by 16. This goes down, why does that keep happening? Down by 8, and this goes down by 4. So now I can see there's a multiplier here. Each of these is half of the previous. So that means that is my B value for this function. So this is h of x. I'll need an A value, but I will have a half to the x power as my B to the x, and then I need to find a K value. Let's do what we were doing before. Let's use 2 of our table values. And so we're doing h of x equals a b to the x plus k. So for the first point, I'm going to have 63, which is my y value. A is unknown. B is a half. And my power is 0. Anything to the 0 power is still 1. So 63 is a plus k. So the first statement is that k equals 63 minus a. Now I need to find another k statement, which I'm going to do by using another point. Same setup, y equals a. We found 1/2 to our b value to the x. Excuse me, my x in this case would be a 1. It's not unknown because I'm using this x and this y. And then I would have plus k. So this one simplifies to be 1/2 a plus k. So my K statement would be 31 minus 1/2 A. That's my other K statement. So putting my K statements equal to one another, 63 minus A has to be 31 minus 1/2 A. So let's see, I'm gonna add this A over to this. So I have 63 equals 31, and then I would have plus 1/2 A. I'm going to take away 31 from each of these. So I have 32 equals 1/2 A. So to solve for A, I'm going to have to multiply both sides by 2, and I have an A value of 64. Okay, so I'm starting to put the puzzle together. I've got my A value, I've got my B value, and now I just need to journey back up to either here or there. And to me, obviously the top one is easier. I'm going to take 63 minus my A value and get -1. So that is my K. So this is the function that is an exponential function tying those values together. So on your homework, in this worksheet, let's see if I can find it. I'm not sure I have it in here. I believe I wrote it down and now I lost it. Ooh, I got it. So now you should be able to do numbers 8 through 11. And I do want you to show all your steps, show all your work, because that's what you'll need to do on our test, and that's what you would need to do on the AP test. And then in day 2, we'll learn how to let our calculators do that, which will be easy peasy. Hope that works, guys. Good luck.